Well, hey guys, this is Avinash. So, this is a kind of quick revision motion in one dimension. So, we'll start this lesson and let's not waste the time. So, what I've done is I have taken all the topics present in this chapter and I have written few important points and also the formulas which are required basically. So, you can also watch on the screen. So, what are there? So I'll be explaining one by one. We'll complete as fast as possible. Right. So motion in one dimension, easy chapter. So first topic is position and position vector. For this, you need to know the knowledge over vectors as well. So let's not discuss that over here, but I'll say how it is actually done. Right. So the first one is position and position vector. So how what it is actually I will say. So suppose this is a point, say A, and now you want to find the position of that point. So when does a position of any point is measured, like how it is found? It's it's only with respect to something. So for that we consider plane, either xy plane or yz plane or zx plane, anything like that. Now here I'll take xy plane. So friends, like for this I want to say one thing, that I have no digitizer or anything. This is a homemade stylus. This is a pen for which I connected a wire. So basically please adjust with my handwriting. So I hope you can see on the screen also. So let's do it. Yeah. So this is point A, and you want to find the position of that point A. So I am considering x and y axis. This is x axis usually, and this is y axis, suppose. So you want to find the position. So to find the position you need to know the distance from origin. So this is origin. So the distance from origin to point A, from origin to point A. So the distance from origin to point A, suppose we'll consider it as RA. So this is the distance from origin to point A. Now you want to find the position vector or position of that particle or point A. Now we'll represent in two ways, like we resolve things. This RA is resolved into two components, that x component and y component, through which we can easily define the position of some body. Suppose this point is xa. Why it is xa? Because the particle is present on x-axis, so I marked it as xa, position of the particle over x-axis. So these many units from here to here, this is xa. Okay, I hope you understood. Next, this is ya. Now as you have seen here, so the position xa I cap plus ya j cap plus za k cap. What is this I cap, j cap and k cap? So I cap, j cap and k cap, I hope you might know that. So that is a representation. That particle is, if the particle is present on x axis, then we represent that particle with I cap. If it is present on y axis, we represent with j cap, and if it is present on z axis, we represent with k cap. That is a kind of representation of that particle. So in this way, if you want to find the position of that particle, we use, so if you want to find this RA, you want to find this RA. So for that, we use this formula. RA is equal to XA I cap plus ya z cap plus za k cap. So here in this example I have not taken z axis, but if you take z axis also, then it might come like, if you use z axis, the particle is something present in the 3D plane. So like this 3 axis will be in one direction. Suppose this is the particle A, so this is x axis, this is y axis, this is z axis. Like this it will be in a 3D particle, and this is the point A. So from here it will be represented like this over the plane. Like if the particle, I hope you might like basic idea you are getting over that. So in this way it will be represented. So but here usually we take either xy plane or, so 3 planes very rarely in this condition we take, so I am just taking it out. This is an exceptional condition. So now you want to find this RA. So you want to find this RA, right? So for this I use the formula XA I cap plus YA Z cap. So here Z axis is not present, so we are not using the Z axis. As you can see this, you can write this, you can note these all points. I'll just rub for you so that it will be easy for you. Going to the next one, we have seen one case, like one particle, we want to find the position of a particular particle, but here two particles, like position of two different particles, like A, this is A, this is A, and this is B. So you want to find the distance between them. Now if you want to find the distance between them, then AB is equal to RB minus RA. So this distance minus this distance, you will get this distance. I hope you might have understood. So RB minus RA, this is RB as you can see here, this is RA, this is RA, you can see here. So RB minus RA will give you AB, and this is the formula, that XB, what is XB? I have previously said you also. So let us see for this also in a detailed manner. Just for this I am just to give an idea, I am just doing this all. So suppose now this is A, this is A, and this is B. Now this is the plane. Now you want to find position, this is A and this is B. Now you want to find the distance between them, between A and B. This is the distance, as you can see, this is the distance. So you want to find distance between A and B, then you will mark it with, this is RB, this is RA. Now RB minus RA will give you AB. AB is nothing but, we'll mark it as RAB. So RB minus RA will give you RAB. So why we are doing RB minus RA? As we can clearly see that like B is much ahead than A. So we are doing like that. Now here I want to say that, like, if you want to find AB, then in vectorial notation only we can write in graphs. So here just a second, yeah, now we have to consider the axis for everything. See, as you can see here also, XB, XA, now we have to take those. how the x like this is the x-axis we are considering in our condition. This is x and this is y. So definitely this will be xa and this will be xb. Now y also we are will take it, y also, this is ya and this only extension of a, so they are present at same level, so this is yb. Now in this way, if you minus xb minus xa, this minus this, xb this, xa this, so this minus this will give you this space, right? Then this minus this will give you xb minus xa will give you this, the distance between a and b. And in case of x, in the x-axis, this much space is there, this much, there you can get here in this way. And in y-axis, what is the difference between their position also? In y-axis also we can find yb minus ya, yb minus ya z is a. So here also we are not considering z-axis, but if z-axis is present, then you need to do the same process. So this is the position and position vector. Let's not make complicate the things. This is very easy one, you can do it. So next topic is distance and displacement. So you know what is distance. So displacement also, the shortest distance is nothing but displacement. Suppose this is a and b and c, and you want to travel from a to c. So a to b, b to c you went, that is distance. But you want displacement, the shortest part is ac, the shortest one is ac. So this ac is the displacement, ac is displacement, ac is displacement, and a to b, a b c, suppose this is distance. I know you know this point. So very most important points of regarding distance and displacement is that just I want to realize that, right? So displacement is always less than distance. Obviously, we know that. Why displacement is always less than distance? Like displacement is the shortest part, hence it is a smaller and equal to distance. So in this, okay, distance is smaller than distance. We agree with that. But when does displacement is equal to distance? And that is what represents this chapter, motion in a straight line. So when a particle is moving in a straight line, suppose from here it's moving in a straight line without any deviation, no u-turn, nothing, it's just moving like this in a straight line. So suppose this is a point and this is b, in a straight line it reached. So definitely distance will be equal to displacement in this particular case, right? Remember that point. Next, distance is always positive. You know that. Suppose this is a graph. Now you want to find the, so like some particle or some car started traveling from origin. From origin it moved like this towards right, that is positive x-axis, up to here. And again it took u-turn and came back here, up to here. Now this is supposed to be 10 meters, suppose, and this total is 15 meters. This total is 15 meters. This is 10 meters. So the total distance now becomes 10 plus 15, 25 meters. But what is the distance? Sorry, displacement. Displacement is only 5 meters, but we mark it as minus 5. Why? It is in negative x-axis. So hence the point is distance is always positive, even though it is in positive x-axis or what, negative x-axis or positive y, negative y, anything. Distance is positive. Remember that. And displacement may be positive or may be negative. So negative case we have seen and positive because positive is generally positive. So negative case in this type of cases. So when we consider like graphical Cartesian geometry, then we have to consider minus. Like the particle is not traveling minus distance. It is a consideration. That's it. Like we consider it to be in minus, like negative axis. It is present in negative axis, so we're considering it as minus. That's it. Moving further, average speed. So average speed delta s by delta t. What is delta s? Speed means distance, so distance by time. So delta is what represents delta also, I have to say, right? So delta is like it represents final minus initial. So here delta s means final distance minus initial distance. It is nothing but s final. S represents distance here. S final minus S initial. So that is delta. So delta S by delta T. Time also here. T final minus T initial. So average speed is, this formula also, speed is equal to distance by time. So distance, so final distance is this much, initial, suppose it started at 1, so the final is 10, so 10 minus 1 9, so it travels some 9 units or like 9 meters it travels. So 9 by some time taken, like suppose 1 hour, so in 9 meters it traveled in 1 hour. That's it, that is the speed. So in that way, right? Moving further, average velocity is similar to that of average speed. It is speed is delta distance by delta time, but average velocity is delta displacement by delta time. Delta displacement by delta time. Here are represented displacement. Here are represented displacement. Moving further. Here one important point I want to discuss again regarding average speed and average velocity. Average speed is always greater than average velocity. Obviously. Why? I'll let you know. Why average speed is always greater than average velocity? I'll say. See, here the part is missing in the photo, so I'll write here average speed is always greater than or equal to average velocity. Average speed is always greater than or equal to average velocity. This is highlighted. See, so speed average velocity, how it is. So what is the formula of average speed? Delta S by delta T, that is displacement by time. Change in displacement by change in time. So speed, distance, change in distance by change in time. So distance is always greater than displacement. So S is equal to delta S, so delta S by delta T. So speed is always like delta s by delta t. So distance is always greater. Distance is always greater than displacement. So if distance is greater than displacement, then numerator increases. Time remains same, so constant. If numerator increases, then it is also increases. Speed also increases. Hence, average speed is always greater than average velocity. Like this is not the thing. This is a mathematical way of teaching, right? So actual thing you can understand. I hope. Like so, more distance it traveled. So in the same given time, more distance it traveled in the same given time. That means more speed. So less distance it traveled. That means displacement in the same time. That means less. So average speed is always greater than or equal to. When it is equal to, it is equal in straight line motion. So average speed is always greater than or equal to average velocity. Then instantaneous speed. What is instantaneous? You want at a particular particular period of time. Suppose I'll explain you what is instantaneous. Suppose with an example and how and where it is used also. This is particle A. Like this is a car moved up to B. A to B it moved. This is about approximately 50 kilometers. In the 50-kilometer journey, car up to this point, it moved with 10 kilometers per hour. 10 km per hour. Up to here, it moved with 30 km. From here to here, it moved with 40 km. This is not a correct one. I'll just stop it. See. So this is the case. So from point this to this, from here to here, it traveled with 10 kilometers per hour. From here to here, it traveled with 30, and from here to here, it traveled with 40. So at different intervals of times, it is traveling with different kinds of speed. But the average speed represents the average of everything. So it is a 50 kilometers road. It's a 50-kilometer journey in some 2 hours. So the average speed becomes 50 by, because we are starting from the origin. So s initial will be 0. Time, so the total time will definitely be 2 hours we took. So 2, so 25, it gives 25. So 25 kilometers per hour is the average speed. Like from 10, 30, 40, these all get averaged. This particular, if it traveled in 25 kilometers, it will reach in 2 hours, right? But this is not the case. Why? Because there is something like the car is moving in different speeds at different intervals of time. How does we actually know? And that is where this concept of instantaneous speed and velocity has come. It gives the speed at a particular interval of time. And here we can see it is ds by dt. What is this ds by dt? So differentiation and integration must for physics, basic rules enough. So ds by dt. What is this d actually is? The instant, it represents the shortest span possible, like shortest span of time possible, or something. Either it is a time or a direction, distance, anything. Short span, very short. So that is it is nearly equal to 0, right? That is represented with d. That is represented with d. So ds by dt, ds by dt. And instantaneous velocity dr by dt, there is no confusion in it. So there is a point over here again, very important point. Instantaneous speed is always equal to the magnitude of instantaneous velocity. So how is this? So you said distance is different from displacement, but how is this instantaneous speed and velocity is same? The magnitude is same. How? That is very simple. See, what is instantaneous speed? You're finding particularly like less than 1 second or something like that. So when you're finding for such a small span of time, then definitely we include average from like 0.1 second to 0.3 seconds, 0.1, 0.1, highlight over here, from 0.1 second to 0.3 seconds, this is seconds. So a body travel from just here to here, yeah, from here to here, this much. Now very small, this is very like very small, right? For this small space, average speed and instantaneous speed like is same, right? Average velocity and instantaneous velocity is also same, right? Right. How, sir? How it is possible, sir? Why, sir? Arey beta, see, here in this short space, distance and displacement both are same, right? There's no deviation, very little space, so that is nearly equal to like straight rod or straight thing, so there's no difference in that. Let just give me a second, I'll be back in a second. I'm pausing like now. Okay, I mean, yes I am. So where we are, so yeah, instantaneous speed is equal to the magnitude of instantaneous velocity. So here distance and displacement are same, hence instantaneous speed and velocity is also same. Moving further, one more point. Instantaneous speed, velocity and average speed, velocity all are same. Instantaneous speed and velocity, average speed and velocity are all are same when they are in uniform motion. Like what is uniform motion? Traveling of some object in equal intervals of times, equal distance, like an object travels equal distance in equal intervals of time, that is uniform motion. So instantaneous speed, instantaneous velocity and average speed and average velocity all are same in uniform motion, because distance is same, displacement is also same, time is also same, hence instantaneous speed is same, velocity is same, average speed and velocities are also same. Now coming to the new topic, that is acceleration. The formula is nothing but delta v by delta t. That means change in speed by change in time. That is acceleration. So only one you can write, both are similar here. So S final minus S initial by S here is speed or velocity by T final minus T initial. That's it. So you know what is acceleration, retardation, everything, right? So increasing of speed in particular time, that is acceleration, and the retardation is opposite to the acceleration, decreasing of time in particular, decreasing of speed in particular time, that is retardation. So acceleration is given by s final minus s initial by time taken, or v final minus v initial by time taken. S or v here, it is nothing but speed final minus speed initial by time taken, that is acceleration. So moving further, the equations of motion, v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2 plus u square plus 2ac. That is, these equations of motions you are studying from 9th standard itself. So I no need to explain you anything like velocity. V is velocity, u is initial velocity, a is acceleration, t is time, s is distance, and u here also same. So everything, that's it. So these equations of motions are compulsory to, like, they're very important, and you know the importance as well, how important they are. So here there's a note point, let me read that. If velocity and acceleration are same in direction, then speed increases. That's it. Very like easy point. See, this is a and this is b, this is a and this is b. So, or else let me take another example now. By this, see, this is you moving in a car. So this is you moving in a car. So I am moving b, I am moving in another car. So you are moving with 5 kilometers per hour speed, or 5 meters per second speed. So I am moving in 10 meters per second speed in the same direction. In what direction you are? And suddenly I hit you. What happens? Definitely your car speed increases. Why? Because here I'm giving some push, some force. That means your body is getting accelerated. Your body is getting accelerated. So as my force is given to your body, that is your car, in the same direction, that is why the speed increases now. Now let's consider another case. You are A, moving like this with 5 meters per second speed, and I am B, coming forward you with 10 meters per second speed, and I hit you. What happens? Now your speed 5 meters per second is in this direction. My speed 10 meters per second is in just opposite to that. That means a negative speed is induced into your body. So your body comes for rest in a fraction of second and immediately increases back. That means minus 5 meters per second speed your car will move with now. So from 5 meters to minus 5 it got reduced. Why? Because they are in opposite direction. But here the point is, if the acceleration, here acceleration is given by my vehicle B to you, right? So if the acceleration and speed of the body are in the same direction, then speed automatically increases. If it is in opposite direction, as in this case, then definitely speed get reduced. Now the last topic, that is graphs. This is pretty very much easy chapter, and graphs plays a major role in entire physics, because we just can't understand few graphs. But how it is actually defined in the graphs, let us see. So linear equation, if a linear equation is given to you, if it is a linear equation like this, y is equal to 4x minus 2, then your graph will be a straight line like this. It's a straight line, there's no deviation. So if there is a linear equation which is given to you, then the graph will be straight line. If x is directly proportional to y, so or y is equal to kx, here k is a constant, suppose. So we generally give it, if there is any proportionality sign, we give it a constant to define it. So if y is equal to kx, it is given like that, then it will be a straight line. Obviously, if x is proportional to y, that means what it says, if x increases, y also increases. If x decreases, y also decreases. Hence, therefore, it will be a straight line passing through the origin, passing through the origin. If x becomes 0, y becomes 0. So straight line passing through the origin. Next one. If x is inversely proportional to y, then it is rectangular hyperbola. What is this rectangular hyperbola? I'll just draw you. Here also it is drawn. This is rectangular hyperbola. See. The graph will be something like half u. So this is rectangular hyperbola. This is rectangular hyperbola. Some rough diagram you need to understand. So this is rectangular hyperbola. Now moving further, quadratic equation. So if there is a quadratic equation, then it represents parabola. Y is equal to 3x square plus 2. So what is parabola? Something like this. If a stone is thrown from here, it travels like this in a parabolic shape and reaches here. That's what, right? So that's what it says. So this represents parabola. So in graphical form also I'll show how it actually is, right? So this is x and y axis. So it's something like this, something like this, from here to here, or some like this. This is parabola. This is parabolic path. So if there is a quadratic equation, so like y is equal to 3x square plus 2, anything like that, if there is a quadratic equation given to you, then the graph definitely represents it's a parabola. If z is equal to yx or y dx or x dx, if z equal to yx or y dx or x dx, then area under that graph is equal to z. Suppose this is x, this is y. Now it is given in the condition that z equal to yx. Now area under this triangle, this entire area under this triangle is z, is equal to z. Area under this triangle is equal to z. If it is given z equal to y dx dy by dx, in that form it is given, then z represents the slope. What is the slope? So this is a graph, so something like this. So this part, this line, either a straight line, parabola, that is slope. So that slope is equal to z when dy by dx condition is given. See, dy by dx, nothing like multiplication, it's division. If it's a division, then it represents a slope. So these are few graphs I have given for you. Like you can just observe them how it is actually in different cases. So see, in the case of uniform motion, so it can be this graph definitely represents like uniform motion, constant velocity increases in constant amount of time. So that is what this graph particularly represents, and this graph represents also the equal intervals of time, it equally increases. But this graph here, I'm sorry, so the velocity remains constant even though time increases, the velocity remaining constant. So this graph represents that, and the velocity increases in the constant amount with time. This particular graph gives that. So this is actually headed with uniform motion, and that's what it represents. Here uniform acceleration, that means acceleration is uniform now, and certain conditions also given here. If u is equal to 0, s equal to 0, t equal to 0, then acceleration this is V and this is T, and this is V is equal to AT, right? These are a few graphs, just you need to observe them. So I'll just make it clean everything, and so that you can take either a screenshot or pause and note down things. And this is the thing, this is the thing. So motion in a one dimension, the next part will go. So this is the last page. So these are also different kinds of graphs, so you can just make note of these graphs how actually given, and just learn them. Here this particular graph is very important in according to me, because mostly these type of graphs are asked. Uniformly retarded, uniformly retarded and accelerated in opposite direction. See, now the body start is here. From here it moved like this. It moved like this up to here. So here uniform, this is straight. That means if there is something a straight line, then it represents equal amount of time in equal intervals. Either it's a distance or acceleration, anything. So it is getting retarded. Why it is getting retarded? It represents a retarded motion. Why? Because it is in the line is moving in downwards, like it started from maximum and reaching the minimum 0 point x-axis. So that is why it represents a retarded motion. From here again the acceleration increases now. That's why uniformly retarded and accelerated in opposite direction. Now this acceleration is negative because it is in opposite direction. Now here one more. So this is what parabola, quadratic equation, I hope you remember. So yeah, I'm actually talking about this, something this quadratic equation, parabola, y is equal to 3x squared, that is what I'm saying. So this is a parabola. Here at the topmost point v is 0, at the topmost point v is 0, it gets rest. When you are throwing a chalk piece, it gets rest. So from here this is a retarded motion, so against gravity, so it is moving retardedly, and up to here it reaches 0, and here comes it again increases its speed, right? Yeah. And next one, so these are something like graph doesn't represent, so it can never be like this. Why it can never be? Because at the same time for a particular particle there cannot be two speeds or two displacements or two distances. See in this graph you can see at this particular time, at the same time, suppose this t, the speed of the particle is something like this, va, and also this vb. So at the same particular time two speeds are there. That is never possible. So hence this graph is wrong. This is a wrong graph. So graphs can never be like this, even at this point also. So it can be like this. So these are few graphs, and how to draw graphs, which graph represents what, which equation represents what, I have given introduction in the previous case, and these just you can just see them, and you can just understand, like these are few conditions given, and the same thing they have drawn, that's it. And at one time two values of velocity or displacement are not possible, as I have said. That's why these graphs are wrong, completely wrong. They are wrong graphs. I had a problem with my pen, that's why. So last topic, that is relative motion. So what is relative motion? Like suppose two trains are moving in the same direction. Obviously one train slows down, but even though it slows down, it will appear for us from this train that it is moving like very fast way than us. But the thing is, mostly it is slow, or either it is slow, or both of them are moving in same speed, anything like that. So in that case, what is that? That is relative motion. So the name itself says it is relating to something, with related to something. Like you can take the riverboat example also. So the boat is traveling with the river's flow. So the boat speed is something like 5 meters, and river speed is something like 10 meters per hour. So both combined it gives 15. So in that way, that is relative motion. So you, if you want to find something like train A is so train A is moving with something like speed 10 kilometers per hour, and train B with something like 20 kilometers per hour. Now you want to find velocity of that particular. I'm sorry for the inconvenience. Yeah. Now you want to find velocity of train A with respect to train B. So what is the difference between them, or what is the relation between them? That is what relative motion. So we are relating some body with other body. So when we related, what is the difference between them? That is what we get in relative motion. So we have seen here train A is moving with 10 kilometers per hour. So VAB here first, there is a trick here. So here first here A comes, means here AB, right? B, right? So that means we are relating A with respect to B. So A is moving with 10 and B is moving with something like 20 kilometers per hour. So the relative motion, the relative speed is about minus 10. And if train B, we take in respect with train BA. So VB minus VA, VB is 20 and VA is 10, then relative motion becomes 10. So it varies in different cases. So relative motion, see, this point is also important, very important. Yeah, obviously, right? See, we get here negative means we get is positive. That is what this represents. It looks so clumsy. So relative motion is not only for velocity, it is also for acceleration. Relative acceleration also we can find. So same formula. So we convert a 2D two body motion into a one body motion, that is relative motion, right? With this relative motion we can there are four different types of sums which can be asked, and very important sums according to me also. So four different types of sums, that is minimum distance between two bodies in motion. Like car A is traveling with this sort of speed, like something like 50 meters, 50 kilometers per hour, and car B is something ahead which is traveling with like 40 kilometers per hour. What is the gap between them, and in what time they can be like at particular time when A crosses B. So in those type of problems can be solved by using relative motion very simply, and in that case also we use relative motion. And Revere-Broad problems, this is the main formula what you need to remember, like x is equal to vr minus vbs sin theta vbr sin theta into w by v cos theta. W by vbr cos theta. So here vr is the velocity of the river. Here Vr is the velocity of the river, and Vbr is velocity of the boat with respect to river sin theta, and Vbr cos theta. So if you do like one or two problems by using this sum, then you can understand. And coming to aircraft wind problem is also similar to that Revere-Broad problem. Like some man is throwing something, like I'll draw the picture and I'll show better. So this is the suppose this is the helicopter, something like this is the helicopter. I'm very bad at drawing pictures. So this is the like this is the helicopter. My stylus is not working properly, so sorry for that. So some boat or some man is here. So he this pilot wants to throw food for him. He can't throw from here. Why? Because he's having some velocity and the particle will deviate like this. So this pilot, so oh shit, yeah. Now this pilot has to throw this food something from here, so that when by the time he reaches here, it is like this. See, he throws this here, so slowly it will come like this to this person. But if it throws here, it deviates its path like this, and this person won't get that food. But it appears like this for the pilot, but from pilot point of view, it doesn't look like this. From pilot point of view, the something like that object or the food pack is moving in this direction, because it is moving along with this pilot, because this particular food packet or something has the same velocity with what helicopter has. So completely it is moving with like this. Along with this, here gravitation acts, and also some kind of force of the velocity of that helicopter also acts over that packet, so that the net force will be in this direction, right? And the net force will be in this direction, hence the object will deviate and reaches this person if the pilot throws like this. If the pilot throws like this, and for that also a similar kind of formula, that is va is equal to vaw by plus vw. So here wind also affects, right? Due to that wind also the packet moves. There are a lot of conditions given. So if you want to find the velocity of the aircraft, then velocity of aircraft minus wind, like velocity of aw plus vw. So velocity of wind plus velocity of aircraft with respect to wind. Yes, solve few problems and you'll understand. So here I don't want to solve problem because It takes much time, and we are only just going on a revision scale. What points are present in this? That's it. And last but not the least, rain problems. Same. And here also, in river problems also, these are few things what you need to keep in mind. T time when cos theta is equal to 1, and if you want to calculate the theta, the angle between the angle of movement also, if you want to find, then sine inverse VR by VBR. So VR, if VR is greater than VBR, then the this point is pretty much important. What, because this is asked in many times, like not many times, few times, at least in school examinations, at least it is asked, or any. So this point is very important. VR, if velocity of the river is greater than velocity of that boat, it never reaches, right? So this is the end of the quick, very recap. This is about, it took a long time, of course, right? It took about 57 minutes, long time. So this is the quick recap. That's it. Thank you. Bye bye. Please subscribe the channel, of course.